Welcome back. In this video, we'll be building on the basics covered in the previous video, hopping off the Arduino board and starting to use external components. The project will be an external LED that can fade through a variety of levels of brightness as opposed to simply turning on and then off. For this tutorial, we'll need an Arduino Nano, a breadboard, a 330 ohm resistor, or thereabouts, and an LED. Our goals are going to be an introduction to breadboards, Arduino pinout, and pulse width modulation. So let's get to it. First, I'll explain what a breadboard is. A breadboard is a prototyping tool that makes creating circuits a ton easier. Below the plastic surface are many rows of electrical contacts that, when you plug components into them, make a circuit. All the rows are isolated from each other, and the columns on the side are for supply voltages. The Arduino Nano fits nicely on a standard breadboard. Now we pick a pin that we're going to use as the output for the LED. If you remember last time, we used pin 13, which illuminated the onboard light. For now, we'll use digital pin 5, located on your board by finding D5. Plug one end of the resistor into D5, and then the other end into a row that is not occupied by a pin of the Arduino Nano. Plug the anode, the long leg of the LED, into the same row as the resistor. And then insert the cathode into the row that is indicated ground, GND, on the Nano. Now our circuit's ready to go. Our code begins very similar to last time, by declaring our pin as an output. So some of you may wonder why we chose D5 here instead of D13 like last time. That's because each pin of the Arduino has different functions that it can perform. Only some pins are capable of PWM output. D5 is one of those pins. So now we go to our loop. The function we'll use here is called analog write, because the PWM output averages to an analog signal. Digital is binary, high and low. Analog is everything in between, inclusive. So we put on our pin here, which is 5, and then our output value. The function takes from 0 to 255 as possible entries here. So let's put the max for this one. This would be just like we're saying digital write to the same pin. And then we'll add a delay of 500 milliseconds. Then we set another output. This time we'll do 175, another delay. Another output. Let's do this one at 100, another delay. And our final one will be at 25, and then another delay. Alright, everything looks good, so let's compile and upload our code. Oh, nice, looking good. We can see how the brightness varies as it steps through the different points that we've set. Next time, we'll learn about variables, types, and some logic, so that we can play with this a little bit easier. Thanks for watching.